I'll first of all start by telling you a little bit about myself. So I'm Atuoha Anthony, and I'm a software engineer, and I think that's all about it. So the topic we're going to be diving into is building scalable applications using Flutter. So from my speaker experiences, when I speak with audiences, I realize that most audiences are coming from the Flutter background, while some are not actually coming from the Flutter background. Some are actually hearing it from the first time. So we'll start by getting to know what Flutter is, because literally, assuming I'm a software engineer or I'm someone that just pivoted into mobile dev, Flutter is more or less when you type it on Google, it gives you this bed, something like Flutter bed or whatsoever. So Flutter, I mean, is Flutter as a UI toolkit which is powered by Google that is used for cross-platform development. So you can use it to build UI for mobile applications, not just mobile applications, for many platforms actually. So Google, from many test cases, has proven to run very well on devices, on Android devices, iOS devices, platforms like web browsers, I mean, Safari, and run extensively on Mac OS, Windows OS, on embedded system, Arduino, and the likes. So Flutter is a framework actually. So it's not like a programming language. It is, you can call it a programming language, but it's not a programming language. It's a framework that is used for building UI, just that it's built with a lot of capability, and it's built in a way that it is how will I put it to you, it is making use of a programming language inside it. So when you're writing that particular programming language, it is very what's the right word to use, it is very easy for you to know, for you not to know when you're writing Flutter, and for you to know when you're writing that. So it makes use of a programming language that's called that. So that is like every other programming language you've come across with, JavaScript, Node.js, Python, and the likes. It still makes use of the same control structure you know about, the same type of variable declaration syntax you know about, and the likes. But what makes it beautiful, that with the Google team decided to go with that, is because of the advantages it has. So that came with a lot of advantages, like the hot reload that Flutter boasts of is being that particular feature is powered by that. The tons of changing code from when you write when you write in Flutter, when you're building it, you're compiling it into the Android. It doesn't compile. It doesn't give you Flutter on the device. Instead, it gives the native language that particular device runs on, which is Kotlin for Android. So all of those things are being handled by that, and that can be right to communicate with your server, to communicate with your backend code, and the likes. So see Flutter as a UI toolkit, and then see that as a programming language. And you don't need to like say I'm learning Flutter and I'm learning that. No, it's the same way. It's the same thing. So while you're learning Flutter, learn how to build a UI of an app. Yeah, as well learning how to make this app efficient, how to use control structures very well, how to use data types very well, how to make use of things in a way that the app is scalable, which is actually where we are diving into in the topic. So that's the whole explanation of Flutter. So currently, Flutter has a stable version of 3.2.4 as of recent. So the section, if you're someone that is already using Flutter, you learn how to scale it more. If you're someone that is new to Flutter, you get started using Flutter. So the first thing here is when you're building a scalable application, you have to think about the architectural design, that is the patterns and the folder structure. So one of the mistakes every one of us make, including myself in the past, is building a project and not structuring it very well, not giving it a design pattern or a project folder structure, not giving it that particular structure that makes it maintainable, makes it easy for someone to jump right into it. So if you're someone that have been um, that is um, that is in the corporate world, you figure that when you get hired, when you go through a hiring process and you get hired, and you start committing code, Like it takes possibly, I think the last job I jumped on a few months ago, a long time ago, a few months ago though, was they gave me 3 days to look at the whole code that's been existing for like 2 years. 3 days, and then I start committing. And most people even get lesser time. Most people get 2 days. So it was just 3 days, the whole thing altogether. And one thing with this is that if there's a helper function that is being written, or there is anything that is existing, you don't get to rewrite it because it's existing. So the more you write code, the more the app size increases. So you have to be reusing component that already existing. So you have to traverse the whole code. You have to traverse the whole code. You have to traverse the whole helper functions, the whole utilities, every single thing within that period of time. So that when you are actually using assets, you need to even look at the assets, even font, get to know every single thing the project has. So the only way you can achieve this as a human being is if the folder, if the project is well structured. Sorry about the noise. I have a little bit. So if the project is not structured very well, you get to go through a very stressful process, a very hiring process, a very stressful onboarding process, which is very bad. And you get to not appreciate the developers have already that in the team. But when the members of the team are using a design pattern, say EM or MVC or MVP, TDD, as in test driven development, or they're using any particular design pattern or folder structure, organizing by feature on all that. It gives you this advantage for not just for you to commit easily and not just for you to join the team easily and start committing or whatsoever. No, the advantage it gives you is that it makes that project more scalable, more extensible, more maintainable, and anybody can jump right onto it. And the beautiful part of it is that when you're building an let's say you're building a social media app using Flutter, and you have chats, you have video call, you have audio call, you have this, you have this. One of the best way to do it is to organize based on feature. And the design pattern I always recommend, that it's not like it's the best, it's clean architecture. That's what I've been using for some years now, and it's really amazing. It helps you not just structure your not just structure your project, but it helps you organize it by feature and a lot of things as well. Separation of concerns and all that. So that is a very big advantage, and that is the first thing you need to look at when you want to build something that is scalable. Say you want to build something that is not just for production, not even just for demo purposes, not just for something you post on your GitHub. Anything you're building, make sure it is something that when someone jump right onto it, they don't get to spend much time. They don't get to spend a whole day or the whole week looking at your code base just for them to write a line of code or them to maintain what you've written as well. So that is a decision you need to make. And the takeaway in this is that there's no design pattern that is the best. All of them comes with advantages, and what matters is team dynamics and what the project requires. So we can jump into a team, you can enter a team or start contributing to an open source project, and you figure that this people are using MVC. So MVC is model view controller, and MVVM is model view model control. Right? Just a minute. Let me just type what MVVM means, please. I've forgotten what it stands for, as you don't cram anything in programming. So it stands for model view model, exactly. So assuming, and I've only used it once and it's amazing. I've used it once in a project. And all of them, what the advantage is that they help you separate consigns. They help you write code in a way that it is very it is in a structured form, or in a feature formatted format. So that's the advantage. And there's no best format, MVP, MVC, clean architecture. They come with the advantage. But you won't say I jumped at him and it's MVP I'm using, or it's clean architecture I'm using. No, it depends on what the project, how big the project is also a factor to consider. So most people tend to use clean of the nature of the project, and I've also seen big projects that are using MVVM. Tons of big projects that I've committed to that are also using MVVM. And most people tend to use test-driven development, where you write test cases first before you even start writing features. So it all depends on what the team needs, and what the project requires. So I think I'll be taking questions to that if there are. Then another thing is efficient use of state management tool and local storage. So one of the mistakes I did as a beginner, even as a programmer, was they used to call it overkill. When you want to do something that is simple, you are doing it in a complex way. You need to create an image, and this particular image you need to create, you need to create a screen, sorry, just a contact screen that has an image, a text, and a button. Instead of you to use a stateless widget. So for those people in Flutter, we know about stateless widget and stateful widgets and their abilities to manage state and change UI based on how it is. So instead of you to use a stateless widget, you went ahead to use a stateful widget, knowing fully well that it is used when there is immutable state, when there is something you're expecting to change, you change to come in and the UI to respond to it. And things like this can actually, and the problem is we actually know the implications of using both stateful and stateless and the performance and whatsoever that it gives, the performance, the load and all that. So you how you should make sure that whenever you are using stateful widgets, you expect a change in your UI. You expect a state to change, not just using it, it's there and it's easy to use. No, expecting a change. Whenever you're building a project, you shouldn't, there are tons of state management tools, block, record, getx, the likes, all of them. I've seen a project where a feature, a particular feature was being a particular was using getx, powered by getx, and another was powered by provider, and another one was powered by block, because it was written by three different people who know these three different management tools and didn't want that one. Such particular practice is a very bad practice, a very, very bad one. And you see most people using a particular local storage tool like shared preference, Hive, and object bus all in one project, making it more heavy, making the project more heavy. And in as much as there is no semantic error or syntax error or whatsoever implication is going to give you or your project is going to have, such practice is very bad. So the advice there is to make use of states when necessary and only make use of one statement management tool, So most people use getx for dismissing of alert buses, dismissing of things and blah, blah, blah. And that would be the reason they will use getx. But it has proven over time that without getx, you can still do all of these things. So you can literally dismiss alert buses, dismiss all of these things, even routing and lot of stuff using tools that are designed for each usage and picking a particular state management tool that is needed for that project. And the same when you're deciding about the pattern to use, that there is none that is perfect, same goes to the state management tool. So most developers, most Flutter engineers go heads on debating which state management tool is the best, if it is block, if it is provider, if it is riverpod, if it's getx. The truth of the matter is there is none that is the best. I've used all of them actually. I started using riverpod 6 months ago, and even though it helps you reduce boilerplate code, and the syntax for you to do something, the syntax is shorter for you to stuff. If you want to something you do in block using a longer syntax, you write it just like the way Python is if it's in Python. So you get to shorter something for a feature that you can write bigger if you are assuming you are writing JS or you are writing PHP. That's how Riverpod is. And it's actually advised by the person that introduced Riverpod for you to use the person that brought in the provider that for you to use Riverpod, that a lot of memory leakage and proficiency and performance optimization has been made in Riverpod, which provider didn't have. So if you're coming from a provider background, it's good for you to switch to Riverpod. But if you're using block, to me, I see no reason for you to switch if the project or the team doesn't require it. That's the simple truth. You only switch, or you only introduce this kind of state management tools when you feel like this particular project requires something like block, or there is a particular thing that you want to use block and do. And the truth is that there's nothing you want to use block and do that Riverport cannot do. And I've not seen something you want to use Riverport to do that block cannot do. That's a simple truth. And the same goes with the GetX. So it's all about team dynamics and project requirements. And in as much as it's very, very beautiful for you to get your hands dirty with all of them and introduce them feature based, it's always advisable to stick with one in one project and build it. It's an advantage. The next thing is right usage of widgets. So this is a very, very big one. So look at this. You're fetching data from an API, and this particular data you're fetching is long, and this long is big. Let's say is up to 30 or let's say 20. First of all, the hope optimization starts from outside this particular one, even though we're going to talk about this. It starts from how the API is created. At least the person that designed it or built it should actually implement pagination. But imagine pagination is not there. One of the ways you can actually prevent a lot of things from both memory leakage, both and not just delays for your UI to be very, very efficient is using list view builder instead of using a list view, using a wrap instead of using a row. So one of the advantages I've learned through the time. So if you go to flutter.dev, so you figure that if you go to the widget, if you go to documentation and go to widget, you figure that there are widgets that you find out that there is this just a minute. Okay, yeah. So there's this thing you find out. You figure out that you can use a row to do what you can use a wrap to do what a row can do. Say you want to present, you want to use you have a button and this particular button or a container, and you want to position two things in a horizontal alignment, like this. You want to keep something here and you want something here. A lot of people would dive straight into using a row, and you use a row, possibly if you want to keep it at the edges, you use your main axis alignment or space between, or you just want to give it a little gap, you use a gap. There is this widget they call gap or a box. But what if I tell you that using a wrap makes it more efficient, makes your UI more efficient, makes it more makes if you're not the size, it doesn't have the size, but it helps you, it helps your app with performance, it optimizes the performance. So there's some widgets you want to introduce into your UI that can be that can be interchanged with a more efficient widget. And one of the things you need to do while building widgets is not to overload your build. So in Flutter, there is a lot of developers know this. So a lot of Flutter developers already know this. Whenever you're building anything and you're calling an API or you're doing a tremendous call on the build, what this happens is that every time you do anything, the build calls. Okay, let's just say you're building a counter app, and this counter app as small as a bit. So when you install Flutter and create a new Flutter project, it comes in with a Flutter app, a Flutter counter project, where when you run it, you can click and it keeps incrementing. If you figure out that when the state is being changed, they are not actually calling the state. They are not setting the state inside the build method. So that whenever you set something inside the build method, what you're saying is whenever this state changes, rebuild everything. And this can lead to a lot of problems, a lot of performance problems. So one of the problems Flutter apps faces is performance. So you see an app during development works very well in your emulator, and when you push it out to the public, they start using it, they start saying the app is hanging. It takes time. It takes time to do this. It takes time to do. Most times not because of network. This takes time to do this. This takes time to do this. Most of the times it's because of a particular kind of things you're using it for. The things you can use cards. So there are some widgets that have high graphical how will I put it to you? High graphics. or the way they are printed, they come with something like a card has an elevated button, has an elevation most of the times, and that's why most people, whenever they're using card, they most of the times remove the elevated button. So the elevation, they always remove the elevated button. So most of the times, what you can do is find this widget that looks heavy and find a way to interchange the widget that are lighter. And that's an advantage. It helps, even if it's just a millisecond that it saves, it optimizes, even if it's just a millisecond that it optimizes. Imagine if you do something like that throughout the whole app. You use things that are not that heavy, layer widget when you need to use them, and just that. Use list view.builder, use grid view.builder. Not the simple truth is that when you're using list view, possibly showcase or display an array of widgets or an array of items, it will still run. But you should ask yourself, why did Flutter introduce list view.builder and it still has list view, has grid view.builder, still has grid view? A lot of people will they will map it. They'll use a list view in the children, they will map it and create an element that will now like look through the whole element. Such practices actually affect in the longer run. So those are like tiny practices that you need to look out for. And the advantage it comes alongside with is the whole, when you're building a two-screen app, it's very easy for you to say my app is fast. But when you start introducing features, 30 screens, 50 screens, 21 dialogues, 60 dialogues, and you have to manage them very well. That's when the practices comes in. And when you're shipping in features, you're shipping in features every month, you're shipping in features every 2 months. If they are not good, if was not optimized, if you are building in a way and using widgets in a way that it is not in an optimized form, in the longer run, your app is going to give you that odd impression that you don't want. And that's a very, very bad one. So on this, okay, so the next one is building with responsiveness in mind. So this is a very big one, and this is one of the challenges everyone is having in Flutter Web. So Flutter can be used, as I mentioned, can be used for both a lot of devices, and I've been privileged to use it for Android, iOS, web, and macOS. Actually, use it for Windows. So the advantage Flutter has is that it writes once, so the same code that runs on iOS is the same code that runs on Android. So the only thing you have to do is now to make platform adjustments. So if you look at your iPhone has this iOS feel. So the iOS feel you get to see in it is that Cupertino feeling, that translucent feeling, where if Apple wants to do anything that has to do with a dialogue, they have this translucent, almost you want to see, you can see it will be as if you want to say it, but you can't see it. That translucent feeling. So that's those kind of Cupertino theme or whatsoever is what separates your code. The dialogue, the timer, all of those stuff, that's are the only adjustments you need to make. Then when you want to run this on a tablet, say you finish building your app, you bundled it as an APK, Flutter build APK, and run it on a tablet. And when you run it on a tablet, you figure out that some tests are tiny because you did not use anything that can make it know if this device screen is big, adjust to this device screen size. If this one is small, adjust it to this. So one of the big setback is not considering device sizes, and that's a problem. It comes with images, grid, and tests, and a lot. So one of the advantages, one of the things you can use to, I think on the screen already, is using media. So you use media query to do a lot of stuff, layout builder. You use orientation builder where you get to see. So you see some games or some applications where if you're using it on, if it's not on rotation mode, it's straight. And if you rotate, the screen adjusts, the content adjusts to how it is. It expands. Most times it's contrast. If there's a text that is long, if it's on a smaller screen, it will have ellipses. So you are considering, Flutter doesn't handle most of this automatically. Flutter handles some automatically for you, but most of it you get to do it yourself. You get to handle it yourself because of when you want to do something and you want it to fit inside a box, you use fit box. You want it to fit it, you want it to be there. So there are tons of widgets that can help you do this stuff. And there are tons of utilities, packages like Sizer and Screen Util that help you also do stuff like this. You get to see your device. So what the advantages you get to know, even as a developer, is to know screen sizes. You need to know that from any width from 800, 860, thereabouts is tablet and anything below it. So you can do with three screen sizes in mind. You can do for the normal iOS, for the normal below 860, above 860, and then the bigger screen. So literally, if you are building an app, except if it is these new iPads that are out. So most iPad screens are not that big. Most of them are extensively big. So you need to also look at and target depending on what you're building actually. So there's some apps actually that you build that you know these are the target audience. These are the kind of screen sizes they use. And another thing is geographical location as well. So when you're building, you need to know your audience as well. So you need to know I'm building. Okay, look at Netflix. A lot of people use Netflix on an iPad. Something like a gaming app is better on an iPad. Something like a fintech app. Uh, okay, I think I've used a fintech app once on an iPad and it was miserable. Even the screen was awful. And you won't be carrying your iPad everywhere. So it's mobile. So something like that, there won't be much optimization, much responsiveness in mind for an app like that because they know that this is a security, this is an app that's personal to you that you won't have to something. That's the way you look at it. So you can target screens in ranges, not that you're going to be covering every device screens. And another thing is foldable devices. So foldable devices are the next thing we are saying where um, I think Flutter also, I think they've written a documentation about it. Flutter has a documentation about it. I'll get to find it and put it in the chat box afterwards. So there are considerations you do for devices like that as well. Devices, foldable devices where they can be like this, and then when you expand it, the screen expands. So there are tons of things you need to look at. So when you're building this, it helps you scale your app to different screen sizes, to different device sizes and all that. So I think that's it. So another key factor in scaling in building an app that is scalable using Flutter is considering performance uptime. So all of this has to do with doing things that help your app get better, optimizing your animations and transitions, your profile and benchmarking. You need to look at your app, the way it is performing. When you write code for an animation, you need to look at how the animation performs. What's the memory cost of this particular thing I'm doing? What kind of memory is it taking? What kind of thing is it? Is if you're someone that builds app and have emulators running every time, you get to figure that when you're running, when your S code is on and your Android Studio is on, if you look at your system, the system, if you look at it very well, you figure that the system is overtasking. So there'll be times I'll be using my Mac and I'll feel like this system is over. Literally, it's not like the temperature is hot or the environment is hot or whatsoever. It has like 5 projects in Android Studio open. It has like 2 emulators open. It has like 3 open, and you're testing it on. Sometimes even the Mac will shut down by itself. That's exactly how the app is like. So there are some things or animations or lot of stuff you do to an app, you give to an app, you figure out that most of these apps will crash. So you used to hear about app crashing. So app crashes when they are not well optimized, when you don't look at this particular. So Google, Flutter came with profile and benchmark where you get to see how your app is performing, which widget is consuming more data for you to optimize it and find a way to optimize it. And most of this way is also catching your image. When you catch your image, there are tools like I mentioned it here, catch network image. So when you fetch a network image, you don't get to network call every single time. Every single time you need this image, you make a network call, and that's very, very expensive. So imagine if you need an image every time a profile image of a user. So this profile image of a user comes in, it comes in from your API, from your user model, from your user service. And you log in, anytime the user closes the app, just like your WhatsApp, every time you close your WhatsApp, open your WhatsApp again, it will start loading that image. That's very expensive. So what you do is when you get that image, you catch it and you keep it. And you catch a lot of stuff. So this optimization also works in local storage when we discuss about local storage. So when you get data, there's some data you get. So if I'm building if I'm building a profile screen for any app, I normally catch the user data. So when what I do is I only fetch it again when you make an edit. So if you log in, immediately you log in, that whole detail is gotten, is fetched. After it's being fetched, it is localized using shared preference or Hive or object bus or whatever you're using. You get to fetch it again when the user possibly changes or maybe makes an edit, send a put request or sends an update to whatsoever. That's when practices like this are tiny, but they actually help your app better in a way that when you start adding features, it's very easy. The current app I'm contributing to has like 4 features inside it, big 4 features. They have a social network, they have a banking app, they have an e-commerce, and they have tons of them. And each of these, we are talking about like almost each one is having almost 500 folders inside them. So and most currently the app is 380 MB, and we've not even done any optimization. So imagine if that app is like that. Nobody would download an app that is even WhatsApp. Check your WhatsApp file app size. Nobody would download an app that you built that is over 100 MB. Goodness me, 80 MB is even too much. Most people download minimum of 30, 20, 18. So these apps have features shipped inside them, but still the app size is very small. So there are things there are ways to optimize it. I don't know if I covered it here, but I'll keep on going forward. So the next thing is testing, debugging, and CI/CD. So you can't talk about building a scalable app if you're not testing what you're building. So you need to write test cases that cover 100%. So you write unit testing. So Flutter helps us with this. Even Block has block testing, and we tools like CodeMagic and TechoCI, but I prefer using CodeMagic. No preference actually, but I like using CodeMagic. So we tools like that, and even we tools like GitHub Actions, and you can write automated tests that run with integration tests. So you can configure your automated test that once you make a push or once you make a pull or whatsoever, before you merge it and check if that particular feature you are writing or whatsoever. I think a lot of people know about this, but it's just that we don't actually look at it very well. So you can't ship a project that has not covered 100%. You can't ship a feature or a method that has not covered its test cases. And one of the ways, even if you're using an API that has dependencies, you can always use Mockito. And this Mockito can help you mock your dependencies and test them. Test how that's why most people prefer to write using TDD, where they write their test cases and then write the feature. So test is something that it can be overemphasized. It's very, very awesome. And that's the reason QA experts exist, QA engineers, people that do SDET exist, because of the fact of tests. So you as a Flutter developer shouldn't actually wait for someone to write test cases for you. Or actually, most of the times it depends on team dynamics and how your team operates. Actually, most of the times, most teams don't give developers privileges to write tests because of time frame. Especially in startup environment, they have QA who write automated tests and tests, but not using Flutter. They have their environment which I don't even know about. So that's another thing to look out for. So the next thing is how you handle asynchronous operations. So I'm not going to talk much about this because of time, so we can take in questions and all that. But one thing you need to realize is that whenever you're doing anything that has to do with handling asynchronous operations in Flutter, we make use of feature and feature builder, streams and stream builder. When you use, and that thing is to know when you use a feature and when you use a stream builder. So if you're building something that listens to events, something that updates in real time. There's this particular thing that I did, but it's not healthy, but I think it's good. Where you get to, if you are building, I think is in Firebase. So literally most stream builder works perfectly with Firebase because of how Firebase is designed. Firebase is actually an amazing tool, and I think everyone knows about it already. So Firebase helps you when you're building. Let's say you have a blog, And this particular blog has different collections, has a blog collection that has different fields, sorry to say. And these fields, maybe image, title whatsoever, you can builder, fetch all of this data that whenever anybody makes changes to the admin and send it to the Firebase, the user doesn't need to refresh. It comes in automatically. So something like that can be handled using a stream builder. You don't get to refresh or do anything. They fetch it immediately, and it can also be done using your API and all that. But the advantage is that it prevents you, it reduces loading time and all that, and it saves you a lot of stress. And also when you're listening to events, single event and multiple events and all that. Okay, so there's something that is not here, which is handling errors. So handling errors is okay, they try and catch. So handling errors is another thing you need to look out for when you are building. So from your when you are when you are utilizing when you are integrating APIs and all that, the way errors are being handled using, I know everyone uses try and catch, and that's exactly what I use actually. But the way errors are handled in a way that they are also okay. I think the best way to say this is whenever you are building anything, build it in a modular form where they are reusable. That create this error class that can take in plugin or whatsoever. So that whenever an error is coming in to like start possibly rewriting a user-friendly error message or in a way that a user will find it appealing or something like that. So one of the key takeaway is also to write functions, even as a Flutter developer that is tagged a front end tags can also have a full stack niche, which is when you're communicating with something like Serverpod or you're utilizing something like Firebase, where you get to communicate with Firebase directly using that. You get to write functions. You get to use abstracted classes and implement them and all that and write services. So these practices are something that you can't overemphasize. You can't even explain in one particular section. It's a very long talk. And the more you build using these tiny practices, the more you get very good at it. And that's the advantage. So this one is just for UI UX. So even as a Flutter developer, you have a say to your navigations, your feedbacks, your lot of stuff actually. So the way your navigation is structured. So in building apps, in building Flutter apps, there are tons of ways you can actually handle your navigations. Go router, which other one? I think it's because I'm using Go router. Auto route, yes. So I use Go router a lot, and Go router is amazing and very, very good. So you get to see that any of these particular practices that you bring to a particular project is what the team uses. So if you say it, okay, take it this way. If you start building a project and you are using strange constants without creating a class of strange constants where these same constants are stored and is being used, you don't get to write these strange constants. There's a class, a file that created a class for strange constants or app constants or whatever constants that you have. And this particular app constant, say production or whatsoever, there's a constant that you don't want anybody to remove, and you bring it on and just write it like that. When the next person comes in, the next person might look for the app. It depends on how the next person is, how the next developer is. But if the next developer is not somebody that has seen, even though the app strange class is just another file that is irrelevant, it's literally irrelevant. But because of you've not done it, they may see that it's irrelevant, and they may not be somebody that have used it before in a single project. So you see app constants everywhere in the project, and this app constant, someone can just change it, and it will be something that is meant to be a strange constant that is the app depends on, or a particular API depends on, or something depends on. So stuff like that are things you separate. That there are a lot of them: app colors, app theming, writing theme for your app. So the list goes on and on and on and on and on and on. So I think the next big one and the last one is leveraging trusted packages only, or you write them yourselves. So one of the problems we Flutter developers encounter is the fact that whenever there's a problem we want to solve, we rush to pub.dev. So pub.dev is amazing, and even I as a user, if you open my pubspec.yaml, you see tons and tons of packages. But these tons and tons of packages are utilized only when I trust them. So I keep getting this question: how do you trust packages? And I think Simon also, the last section we had at GDG London, he also mentioned it, and I got some feedback from him. So he mentioned something that is very, very wonderful, which I've not heard, is likes. Look at how many people that have liked it. So when you look at when I open something like let me open something like Google Alt, Google Alt pub.dev. So let me open something like this. Okay, Google sign in or Google Auth, any of them. So when I put something like this, so see what you get to see. Okay, not this one. This one has one. So literally, I'm not sure I'm going to use this. So let me say this. Look at this. This is 3.1K. So it means that 3,100 developers actually have used this and trust it. Another thing is, this is not that necessary, but somewhat necessary is to look at verified publishers. So I've used packages from unverified publishers that are very amazing. The thing you should look out for is this. And also look at for if it is DAT3 compatible. So you get to see if it is DAT3 compatible and if it has an analysis issue. So I've seen packages that have analysis issue that still worked, but they always fail at some point. They may be discontinued, they may be duplicated, they may have a particular, and you know, Flutter keeps shipping in new updates. They keep on shipping in new updates. So it means that anything that the community is following or is maintaining or is following up is something that stays of what that brings to the table, what Flutter brings to the table, and that's it. So that can be overemphasized. Thing is for you to dive into Flutter. So if you are new to Flutter, and the advantage is that most people as just a framework or just another cross-platform tool out there. But the advantage is that when you write to Flutter, it gives you that particular native feeling that you need in that your device. So assuming you're building for iOS and you ship your app to the Play Store, when you download it, you get to choose if you want it to be bundled with Objective-C or Swift. So you get to choose. So it means that if you're running it, it's bundled as a Swift, it's bundled as something that is built using Swift, even though it is written with Flutter. And that is something that is amazing. So the Flutter team is really doing an amazing job there. So thank you for listening. I'm Atuoha Anthony. So you can find me on LinkedIn and on Twitter. I'm more active on LinkedIn. So you can always get me. So this is me. So you can always get me. So the front links you see here, you can always contact me, and that's it. Thank you so much. Okay, let me look at questions. So, okay. Network images. Okay, Michael asked, catch network images using shared preference or hives. No, so when you're catching network images, you don't need to use hives or a shared preference. You use a package called cached network images. Cached network images. Don't mind me. I'm a Nigerian. Cached network image. So this is it. Yeah, this is it. So you see the kind of likes it has. So it has up to 6.3K. So with this, once you have a network image, and so you just go through it, go to the example or the installing and go through it. Once you make use of something like this, it means that it fetches it only once. So the package handles everything for you. That's the advantage of using packages, as I mentioned. So once it gets a network image, it will catch it inside it and keep it for you. Even if you close the app and get it back again, it doesn't reload, it doesn't fetch it again. It handles every single thing for you. So you don't have to use a local storage tool like shared preference to store it separately. No, the package handles it for you automatically. So that is it. So thank you so much for listening, everyone.
There is an additional question. How does one reduce app sizes?
Okay, yes. I appreciate how does one okay, yes. So that's a very big question. So for you to reduce app sizes, it comes with practices. One of the practice is whenever you are building an app, you have assets that you make use of. Fonts, what they call it, fonts you bring in from font files. You go to Google Fonts, you bring in fonts, you bring in, maybe you have from the UI design that the designer designed. There are tons of fonts there. Maybe the person is using Roberto, using this one, using this one, using this one. A common Flutter developer will just rush and download all of them and put them inside the folder and create a font and then call it an pop spec. But imagine that there is actually a package that is called Google Fonts Pop Dev. If I go to Google Font Pop Dev, so I can actually use this package only. So you see that a lot of the developers are using it already. So you see how it is being used. So I don't need to bring in any of these fonts again. So I just bring in this package, which is very, very tiny, and I can access any kind of font again. So that this saves you a lot. Like, it reduces your app size a lot. So reducing app size is not like something you press one and it happens. It comes with the kind of practice you bring to the team, to the a lot of kind of practices you bring to the table. Next one is assets. Images are heavy, very, very heavy, like as heavy as you can think of. So if someone is GIF and tons of stuff, let's say a design has tons of images, one of the ways you can do is to reduce image sizes. There are tools online that you can actually use to reduce image sizes. You reduce image sizes to the smallest size you can think of, and make sure that you are using the assets because they are necessary. If you're using an SVG, say the first time I started using SVGs as a Flutter developer, I used to export them inside my folder and then call them up using SVG picture or using other tools. But the SVGs you see, they're actually part of icon sacks. So there is this package that is called icon sacks. As I mentioned, it's a very long, this is a practice, it's like a list of practice of things you need to do. That when you are building, you get to use assets that are only necessary. You get to use things that are only important to reduce the app size. So the first time, look at this. Assuming you okay, just a minute. Assuming you open any particular what they call it, any particular UI design or whatsoever to open, you get to see some kind of fonts that you've not seen. That was one of the things I experienced earlier in my career. I get to see some fonts, and then you always have option to export them as SVG, and you get to start exporting them and bringing them to you, and then start accessing them and all that. Those SVG are like KB. Their sizes are 2 KB, 1 KB. But imagine if in an app that has like 2 features or 3 features or 4 features, you are exporting over 400 KBs. Times it increases. So the app size is directly proportional to the kind of assets you are using, and I think it's just directly proportional to the kind of assets you are using and the files. So most of the times, the files you are creating are not heavy, but asset files are heavy. So that's another thing you need to look out for. So you use assets when necessary, and I think that's pretty it. So most of other practices you can get to see are practices that related to another one before I say that's all, modular programming. So when you build widget, you don't get to create more. So if I want to do anything in when I start building an app, I create helper classes, helper functions, modular helper widgets. These helper widgets are widgets that I can reuse across all my app. So if I have an alert boss, I don't get to call up alert boss again. I create one alert boss, customize it in any form it can ever be. If there are constraints that are tied to it, anything, I create them as parameters that are optional or if they are required, and I get to use them once. So it then means that will be used only once. If there's any particular make to Firebase or I need to make to an API, and there's a way for me to like make it in a way that I get to do it and have it only once. So practices, I think the beautiful part of it is that when you're building to scale an app, you're actually building it to also optimize the app size, and that's an advantage one. So it all rounds up to you being that efficient programmer that you need to be, and that is it. So I don't know if that answers the answer, but these practices are what I've done. And if the app size is big, it then means that the project is big. There are some sizes that you can actually get free because of feature based and stuff. But as a developer, you should find a way to make sure that the practices you're following and all of the things you're doing are optimal, so that when there's external auditor or head of engineering or whoever that is looking at your code, they'll know that this file, this app size is 80 MB because it's 80 MB. Actually have it is, except if you can split it. So that's why you see some apps having Uber Drive and user app. Most of the times, it's not just because of they want to split it. Most of the times, it's because of app size. Most of the times, it's because they want it to be faster. They want to optimize it in a way that is fast. And you keep on asking yourself, why go through the stress of building for this and building for this and going through app review policies and Play Store review policies? Is because of optimization most of the times. So that is it.
All right. Well, thank you everyone for joining today. It was an amazing session. And again, this will be recorded and it will be uploaded to our YouTube channel. Again, thank you so much, Atuoha, for joining us. It's been an honor and a pleasure to host you. And yeah, enjoy the rest of your weekend. Thank you, everyone. See you later.
See you later. Thank you.